Hello everyone, welcome to today's lab, and we are going to do lab 8 today, which is AC circuit analysis, right? So already you know this is the schematic diagram, and we're going to use signal generator channel 1 DC, this portion, to provide our RMS voltage as an input voltage today. So as per the circuit suggests, it's a 3 volt RMS, 3 RMS voltage we have to supply, right? So I just use this formula, like if you use peak to peak, then you have to divide it by 2 square root of 2, and once you get this from here, I want VRMS to be 3, right? So I divided it by 0.3536, and whatever the peak to peak value comes, I just gave that as an input over here. The frequency, I set it at 1 kilohertz, and then when I have this circuit configuration, to make sure that my circuit supply is okay, and then I set this PSU at 11 voltage, and then you can see the RMS value comes around 2.98 or approximately 3, right? So that's the first thing. Second thing is, if you take a look at table 1, you're gonna see you have to put the value of the measured values over here. So like, even though you are using 47 ohms, so that 47 ohms might be 47.5 ohms, or it can be 46 ohms, right? So just try to measure those and then give those as an input over here. So this is something that you are gonna need to use later on in this project, which is to get the values of the inductor and the capacitance. So capacitor. So for the inductance values, even though it's mentioned it's 110 millihenry, but still this is the way of actually calculating the inductance, which is the first digit times 10 to the power 3 K. You are gonna see this kind of label on your inductor, right? So you this 3 is the multiplier, which is 10 to the power 3. So 22 times 10 to the power 3 microhenry is the unit. So if you see it for your particular inductor, you're gonna see it's 100 millihenry, right? So it's not actually 110 millihenry for our case, it's 100 millihenry. And the capacitor value likewise. So if it's 47 3J, J is actually the tolerance, forget about that. So 47 is 47 times 10 to the power 3, and the unit is picofarad. So if you do that calculation, you're gonna find you're using 0.22 microfarad, okay? Then use the value of the resistances. You're not gonna be able to need L1 and C1 for this, but you're gonna need it later on. And then what you do is you construct the circuit next, and after you construct the circuit, you're gonna have to measure the voltages across R1, which is 47 ohm, then this one, not the capacitor, okay, just across this R3, and then RS. You're gonna have to measure that. And we are not going to measure the branch current magnitudes. You know the reason? The reason is because our multimeter is not capable of measuring the AC current. That's the reason why we're not going to measure this. Rather, we are going to calculate, and then we are going to move forward, okay? And after you take these readings, of course, complete table 1, and then you move over to figure 2. So this is just the way I constructed my circuit. What you have to do is follow the step 1 to 5 of series RLC circuit, and then you have to complete the table 2 readings, right? So for table 2, it's pretty much straightforward. So for table 2, when you are trying to read the voltage across VR1, which is this one, this 47 ohms, for me this is this portion, right? So sometimes I was getting 0 when the frequency was 500 to 700 hertz. See, the value is very, very less, and our pointer is towards AC voltage of 250 volts max. So it's reading in volt, but still we are getting the readings in milli or even microvolts. So if it is very, very low, then it doesn't show up. So you don't have to panic about that, okay? So 500 to 700, you might get 0, but for other ones, you're gonna get the proper values. After completing table 1, you are also completing table 2, right? So just one thing you have to know, that is the inductor and capacitors, the impedance. So how do you calculate the impedances? So for inductor, it is JXL. So XL stands for 2 pi FL, right? So it's gonna be J 2 pi FL, okay? Where it is the where F is your frequency. So what happened is, like, when you set this RMS voltage, you set your frequency over here as 1 kilohertz. So over here your frequency is 1 kilohertz, right? Similarly for capacitance, it's gonna be, instead of 1, it's gonna be J. So J over 2 pi FC. Okay, it's pretty much simple as that. Now, why would you need this? You're gonna need this for table 5 and table 6, of course. So also for table 3. So in table 3, you're gonna see, they ask you to calculate the what should I say, the impedance, right? So for branch 1, if you want to calculate the impedance, let's say this is your branch 1, right? So if you want to calculate the impedance of this branch, it's going to be the resistance of R1, the resistance of RL, and the resistance of this. So you don't get the resistance for inductor and the capacitors, right? You get reactance. So for reactance values, that's JXL for L1, which is for your inductor, and for capacitance, it's actually J over 2 pi FC, J over XC, right? So over here I just did one mistake. It's not JXC, it's J over XC. Okay. Now, so in table 3, you are gonna definitely use that. For example, 47 ohms plus 23 ohms plus what is the the impedance of this L1. Like I said, you use this formula to calculate the impedance. It's gonna be J something, so it in total it becomes a complex number, right? Similarly, it's gonna be a complex number for a capacitor. So what you do is just simply straightforward use MATLAB to perform this kind of operations. Okay, because MATLAB gives you proper, it's gonna make your calculation a lot easier. For example, like you wanna use, you're first using first you are using in calculating the impedance, and then you are doing the inverse of that to calculate the admittance, right? If you look at table 3, so when you want to inverse the complex number, if you use MATLAB, that's going to be way easier for you. Okay, and then for table 4, you are not going to use no measured values of the current, so no percentage error comparisons, right? So there are straight formulas. So using that straight up formula, you're gonna first calculate the rectangular current and other parameters that they ask you to calculate in table 4. That's the first column. Then in the second column, when they say to convert from rectangular to polar, what you're gonna do is you're gonna go to this particular website, that intmat.com. Over there, when you type complex number polar rectangular to polar conversion, then there is going to be a website that's called IntMath. So go to that website. Over there you are going to find a section where they convert the rectangular complex number into a polar complex number. So convert that and then put them in table 4. Okay, and then table 5 and table 6 is pretty much straightforward. So for 500 hertz, you're not gonna use that, okay, because sometimes you got the current as 0. But for other frequencies, you could calculate the current because your VR1 was not equals to 0, right? Because it was, around 0.1, 0.2 volt, something like that. So over there, you could calculate your currents, right? What you have to do is you just fill up this column, and then over here, obviously the polar and the measured we are not going to compare for the current, but we are going to do the same for the voltage of the capacitor, the voltage of the inductor, and the voltage of the resistance. And then you just fill up your circuit. Even if there is a difference, don't mind about it. As long as your readings are correct, I'll know that you're, I'll give you points. So you don't have to worry about that. So that's going to be all for today's lab. And if you have any questions, you can definitely ask me in the session, right? So good luck.